Nozzle is one of the steady flow engineering device. Nozzle can be defined as a device that increases the velocity of a fluid at the expense of pressure. A nozzle is often a pipe or tube of varying cross-sectional area. Nozzles are typically categorized as a convergent nozzle and convergent divergent nozzle. Convergent divergent nozzle was invented by a Swedish scientist named Gustav de Laval in 1998, and now the nozzle also known as de Laval nozzle. Convergent divergent nozzle is now being used widely, for instance in the case of supersonic version of missile, jet engine, and wind tunnel. However, both types of nozzle have serious application in industry and technology. Air nozzle is one of the examples for convergent nozzle. Air nozzle is used for dispersing air or steam in a concentrated and straight fan. In addition, air nozzle is one of the most common products used in the factory environment and can also be used for cleaning, cooling, and drying parts.
So, how does air nozzle work? The structural characteristics of air nozzle is made with a conical shape-like structure with fixed volume. It has no shaft, pistons, or any mobile boundary. The cross-sectional area of an air nozzle decreases in the flow of direction. This means that the exit of air nozzle has much smaller space for air to flow compared to the inlet. So this animation is an example of the mechanism of air nozzle. Firstly, air enters the inlet of the nozzle. As it flows through, acceleration occurs. As mentioned, the cross-sectional area of an air nozzle decreases in the flow of direction. Thus, pressure also increases along the nozzle. In general, the pressure at the exit is the highest and at the inlet is the lowest. Pressure is defined as the ratio of force and area, which explains why the pressure of air builds up at the nozzle outlet. Continuous acceleration along the nozzle allows air to travel at a faster velocity at the exit with the expense of pressure. Based on the first law of thermodynamics for a control volume, the change in mass within a control volume, in this case the nozzle, is equal to the mass entering the control volume minus the mass leaving the control volume. Thus, the rate flow of mass remains steady along the process. There is no work taking place in air nozzle because it has no movable boundary. Next, the temperature of air flowing through the nozzle might slightly decrease due to the conversion of internal energy to kinetic energy. However, the process involved in air nozzle is considered adiabatic because there is no time for heat transfer due to high velocity, and if the temperature drops, it does not show any significant changes.
Entropy is described as a disorder. Entropy is generated or created during an irreversible process, and the generation is due to the presence of irreversibilities. The total entropy of a closed system is always increasing is another way of stating the second law of thermodynamics. The second law of thermodynamics states that entropy of a system either increases or remains constant, but it never decreases. As the matter and energy travel through the nozzle, there are friction generated. Friction force dissipates power and generates entropy. The change of entropy can be described as change in entropy equals to change in energy over temperature. Therefore, as energy increases, does entropy increase too. Nozzle is a reversible process. According to the second law of thermodynamics, whenever there is a reversible process and adiabatic flow, constant value of entropy is maintained. In this case, the constant entropy is classified as an isentropic process. In isentropic process, the formula are as follows. Initial entropy equals to final entropy, or change in entropy equals to 0. Therefore, there is no change of entropy in the steady flow system of a nozzle.
In conclusion, this report provides outline of how entropy occurs, nozzles and its types. entropy occurs during irreversible process due to irreversibilities. The total entropy of a closed system is always increasing, which states the second law of thermodynamics. Whenever there is a reversible and diabatic flow, the constant value of entropy is maintained, which is classified as a isentropic process. For nozzle, it's often a pipe or a tube of cross-sectional area, and they are characterized into two. The first one is a conversion nozzle, which is used for dispersing air or steam in concentrated and straight fan. And the second one is a conversion diversion, which is used widely in case of supersonic version of missiles, jet engine. However, both types of the nozzle have serious application in industry and technology.